Hi everyone, I'm Tiana.
My name is Waleed.
I'm Connor.
I'm Alex.
I'm Ryan.
And I'm Andrew.
And we're here today to talk to you about related rates, which is an important concept in calculus. The idea of related rate is to find the rate of change in one quantity in terms of the rate of change in another quantity.
There's nothing these kids learn in school they can't learn on the street.
It's 3 o'clock. Where the hell is Louis?
Well, you tell me. Louis left his house at 2:15 and has to travel a distance of 6.2 miles at a rate of 5 miles per hour. What time will Louis arrive?
Depends if he stops to see his hoe.
That's what we call a variable.
So here's the problem. Car A is traveling west at 50 miles an hour and car B is traveling north at 60 miles an hour. Both are headed for the intersection of the two roads. At what rate are the cars approaching each other when car A is 0.3 miles and car B is 0.4 miles from the intersection?
Before I go into the solution, I just want to remind everybody, calculus and alcohol don't mix. Never drink and derive. So as you can see from my little visual here, I have everything mapped out. We have X is the distance from car A to point C. C is the intersection of the two roads that you can see right here. Y is the distance from car B to point C. And we're finding it with respect to t equals time. And z is the distance between both cars. We're asked to look for the derivative of z with respect to t. In my second step, I have x, y, and z are distances measured in miles. We're given that derivative of x with respect to t is negative 50 miles an hour, and the derivative of y with respect to t is negative 60 miles an hour. However, the derivatives are negative because the values of x and y are decreasing. X, y, and z can be related using the Pythagorean theorem, which is very basic. So we know now that z squared equals x squared plus y squared. In my third step, I'm just doing some basic algebra and calculus to get the final answer. So in order to get our answer, we must differentiate each side. First of all, we have z squared equals x squared plus y squared. After differentiating, we get 2z times the derivative of z with respect to t equals 2x times the derivative of x with respect to t plus 2y times the derivative of y with respect to t. After that, we do some basic algebra and dividing both sides by 2z. So we get the derivative of z with respect to t equals 1 over z times the quantity of x times the derivative of x with respect to t plus y times the derivative of y with respect to t. After this step, we just have to substitute values. We know that x is 0.3 miles, y is 0.5 miles, y is 0.4 miles, and z is 0.5 miles using the Pythagorean theorem. So now we get the derivative of z with respect to t equals this. We just plug in values, we just do some basic algebra, and our final answer is negative 78. The cars are approaching each other at a rate of 78 miles an hour.
A man walks along a straight path at a speed of 4 feet per second. A searchlight is located on the ground, 20 feet from the path, and is kept focused on the man. At what rate is the searchlight rotating when the man is 15 feet from the point on the path closest to the searchlight?
As you can see from the visual of the problem, x is the distance from the man to the point, and theta is the angle between the beam of the searchlight perpendicular to the point. We are given that the derivative of x with respect to the time equals 4 feet per second. However, we are asked to find the derivative of the angle theta with respect to time when x equals 15. Here is the equation that relates x and theta. X equals 20 times tangent of theta. We're using tangent because we are given the opposite and adjacent sides of the angle. In step 2, we have to differentiate each side with respect of t in order to obtain our value. We already knew that x equals 20 times tangent of theta. Now we have to differentiate each side. After doing that, we must isolate the derivative of theta with respect to time. After we substitute the value 4, we get 1/5 times cosine squared of theta. Now, when x equals 15, the length of the beam equals 25, so cosine theta equals 4 over 5. When we plug it in, our final answer is that the light is rotating at a rate of 0.128 radians per second.